Hey, this is Dexter. In this lesson, we will learn how to apply the quotient rule and chain rule of differentiation. We will also learn about the second derivative and the increasing-decreasing function. The equation of a curve is given to be y equal to 4 over x squared plus 1. In part 1, show that y is the decreasing function for all positive value of x. In part 2, find the range of x for which the gradient of the curve is an increasing function. Pause to give this question a try, and when you're ready, keep watching to learn how to solve this problem. To show that y is the decreasing function, we need to prove that the first derivative is lesser than 0. Applying the quotient rule of differentiation, we'll begin by squaring the denominator of x squared plus 1. Then, we'll copy the denominator of x squared plus 1 and multiply it to the differentiation of our numerator. Differentiating the constant 4 will give the result of 0. Next, we shall subtract the numerator, followed by the multiplication of this denominator. Differentiating x squared plus 1 will give the result of 2x. Simplifying the numerator will give us negative 8x divided by the square of x squared plus 1. Given that x is positive, then the square of it will be greater than 0. And adding 1 to x squared will still be positive. Squaring a positive result will still be positive, and thus the denominator of the first derivative will be positive. As x is positive, negative 8x will be negative, and therefore the numerator of the first derivative will be negative. Thus, concluding the first derivative to be lesser than 0. Hence, we have shown that y is the decreasing function for all positive values of x, and that is the answer to part 1 of this question. To find the range of x for which the gradient is an increasing function, we need to find the second derivative of y, which will apply the same quotient rule of differentiation to our first derivative. Like the previous part, we will begin the quotient rule by squaring the denominator to give us x squared plus 1 to the power of 4. Next, we will copy this denominator and multiply to the differentiation of our numerator. Differentiating negative 8x will give the result of negative 8. Then, we copy the numerator of negative 8x before multiplying to the differentiation of our denominator. To differentiate a composite function, we will now apply the chain rule of differentiation, where we first differentiate the outside by bringing down the power and power minus 1. Next, we differentiate inside the parentheses to give us 2x. Then, we factorize out the common terms of 8 times of x squared plus 1 in the numerator, so that we can cancel out x squared plus 1 to both the numerator and denominator to give us this second derivative results. Given that the gradient of the curve is an increasing function, we will now set the second derivative to be greater than 0. Since x squared plus 1 is greater than 0, cubing a positive value will give a positive answer, making the denominator to also be positive. And for the fraction to be positive, the numerator must be greater than 0. Factorizing this quadratic expression on the left, using the special algebraic identities of a squared minus b squared to be equal to a plus b times a minus b, will give us root 3 times x plus 1 multiplied by root 3x minus 1 to be greater than 0. Let's now solve this quadratic inequality by the graphical methods. For the quadratic to be greater than 0, we will use the part of the curve that is above the horizontal axis. That will mean x to be lesser than negative 1 over square root 3, or x to be greater than 1 over square root 3. We will now rationalize the denominator by multiplying root 3 to both the numerator and denominator, to give us a result of x to be lesser than negative root 3 over 3, or x to be greater than root 3 over 3. And that's the answer to this question.